Awasthi. Sorry. And today I'm going to present this enhancing PyGILE ecosystem for high performance computing. Actually, I'm a doctorate student at Asian Institute of Technology. So this is actually mostly related to the workshop that we conducted yesterday about PyGILE and PyGILE Plus. I see some familiar faces who actually attended the workshop. However, I'm going to go through what PyGILE Plus is, and going through this ecosystem, we're trying to figure out how this is, how this came up, and how this is useful and being used into the geospatial world. So this is the outline of the presentation that we're going to go through. Some introduction, some use cases, and some trying to see like why and how this could be useful for geospatial scientists. So to introduce PyGILE is a Python geoinformatics live environment. So let's look this in such a way that let's say a researcher or someone who wants to go through using Python comes up with an issue that they want to install some Python packages, and they're going through something called a dependency hell. Means they're trying to install one, and again they're trying to install another because of the different versions. They're not being able to configure. So different environments, you're trying to create one for your one project and another environment for another. So that kind of creates more time. We spend a whole lot of time creating environments rather than working. And this actually works, is the same thing with the educators as well. Whoever is teaching, they're having the same issues. So this PyGILE is a pre-configured environment where we'll have majority of geospatial packages already pre-installed, and all we have to do is we have to run something called Docker container that we'll go through later on, and it's containerized in such a way that all of those packages are built in an image that will not be affected by any of the version upgrades, and we can just, they are ready to use. And here in this PyGILE, if you scan through, in the GitHub repo, you will find some Jupyter notebooks that introduce Python, that teach us about the foundations of the geospatial in terms of the vectors, the rasters, and different workflows and all that. So this is the same thing that we discussed, mostly about how this is a cross-platform environment. It can be installed locally. For instance, we've used something called Miniforge. Miniforge is the Mamba-based solver, which is a bit faster than the Conda one. And it can be used in the localized environment, or we can just pull the Docker, a containerized environment that we have uploaded in the Docker Hub that we can just pull and ready to use. So these are some notebooks, the modules that we will find in the PyGILE ecosystem. The PyGILE Jupyter. So there are some fundamentals, spatials. I mean, this is for a geospatial person, this would be quite foundation thing. However, for someone who's new to the geospatial world, who is learning these things, this is extremely useful. We went through some of this during our workshop as well. And these are some snapshots, like these kind of things are given there with the interactive visualizations. With the code, we can play around. Although we had PyGILE, there was some missing. So the missing part was, what if somebody wants to use with GIS, like not just the Python packages? And which GIS to use? There's Saga GIS, there's GDAL, there's Grass GIS, there's Orfeo Toolbox, there's Whitebox tools. There are so many other things that can be actually utilized in the geospatial field. So which one to use? So again, going through one at a time, trying to find and install this and that, it takes a whole lot of time. Then we thought, why not add all of the existing PyGILE packages into creating something new called PyGILE Plus, where Saga GIS, Grass GIS, Whitebox tools, and all of these will be in a singularized, containerized environment alongside the PyGILE. So what this means is, you just need to run one command. You need to pull something, and once it's installed, all of this in a headless environment, you have it in your system, and you can just run all the GIS, seamlessly. So this is just an example of how this we can start. And these are some core geospatial packages. I believe almost majority, I don't actually want to give a number, but majority of the geospatial packages are already here, including the GISs. So as you can see here, for instance, for me, I'm a geologist by profession, and mostly I work with these landslide and disaster field. So I need data, and I use GIS in such a way that I have to be able to use the packages as well as the GIS inside at the same time. So that's why this PyGILE Plus is a very effective use case for me. So this is one of the examples where we're trying to get the factor of safety of a terrain. So for that we need these kind of all of these things. So for the soil thickness map and for the wetness index, so I do not trust a single GIS. So I mean, all of them give the same result, but I like better. For instance, for hydrological analysis, sometimes I use Saga GIS because I like it better, or I use white box tools. So, and for, let's say, for simple morphometric analysis like slope and aspect, those kind of things, I might use GDAL or even GRASS, or even for advanced, definitely I would use GRASS. So all of those in a singularized environment, so it is useful. This is just for different rainfall thresholds in a region. Now, the reason I'm showing you all of this is, even with all of this PyGILE Plus, there was a situation when I had to do the same thing, same factor of safety, but not just for a localized region, but for a regional region. Now, how should I do it? My computer was not efficient enough to do it. So then we thought of something called, what if we could move this, we could convert this Docker that we already have in PyGILE Plus into a high performance computing. How can we convert this and we could use that there? So for that, so first let's go through what we have here. So it's headless, means we do not support the GUI here, because for that we already have others. And so for this PyGILE Plus, we had to build from the source, the Saga GIS, the latest one, because for Saga and GRASS, the apt versions were there, but the latest one we had to build. And building the Docker image with all of these together created a lot of chaos, to be honest, because there were so many dependencies to look through, and we have been able to create it. So it is now for all of others, we just have to pull and use. So the dependency hell issue is not going to be there. Another reason that we really wanted to do this is because of reproducibility. There was I'll tell you a short story, like with one of my friends. So he went to a workshop and he learned something about hydrological aspects. And the presenter there, they gave like a tutorials and a lot of things. When he went home and when he tried to do it, he couldn't replicate it, and he even gave me the code and said, just try if you could do it. And I couldn't as well. So the reproducibility factor is always an issue, and even in the environments, and especially for the educators, like here, I mean, a lot of us, a lot of you may be teachers, and a lot of students have different operating systems and they want to work. We don't know what a student is going to install and how to make it in such a way that everybody installs the same system and it will be easy to work rather than spend a lot of time on it. So that part is also covered with this PyGILE ecosystem. And this works on my machine problem. Yeah, this, like, even the research shows that only 70% of researchers, only 30% of researchers can actually reproduce their work. Either it's like, I mean, there is no guarantee that it's going to work in the other systems. And to make this possible, yes. So what we did is we created a container. So let me go a little bit about what is a container. We talked about containers. So container is something that we create all of whatever we require in terms of the GIS, in terms of the packages, whatever we're saying, into a singularized image that after building will have everything inside, and we do not have to go outside of that container to use it. So, and all of those dependencies are already inside it. So now for the Docker is a tool that we can create, with which we can create this container, an image and then a container. So this we already had with PyGILE Plus, but the thing is it's not secure enough because it requires the root privileges. So for this, and also because of the issue that if I want to do something for a regional level or even a national level, my PC, my localized PC will not be sufficient enough to be able to produce those stuff. So for that we have something called singularity. They call it Aptainer these days, I think. And so what it does is, it's just a single command. So using that, we will just convert this Docker into a zip file, and that zip file we can use, the same thing we can use in a high performance computing. So now we have all the Python, majority of the Python packages, we have GIS, and now all we need to do is, and we have the HPC as well. So based on our clusters, we can separate the whatever we want. I mean, how much is the data that we require, or the computational power that we require. Based on that, we can use it. So these are some issues that we faced while building the PyGILE Plus. So yeah, I mean, with these issues everybody gets. So these are not any new issues, but the thing is to get that in particular environment, solving all of these issues together was kind of tricky. And although we were able to do it with different solutions, as like sometimes we had to pin, sometimes we had to compile. So however we were able to do it. So overall framework is like, so using this Mamba framework, first the Conda solvers, those part of things we used using the Mamba instead of Conda. And the headless rendering support, the GIS dependencies were cleared, the Conda scientific stack, the Grass GIS, and all of these were to be visualized in the Jupyter framework. So now for the HPC, again we go back, like scaling with the HPC with Aptainer. There's just a single command that can convert the Docker images into a singularity format. And since it doesn't require any root privileges, it is considered safe. And it supports the communication, high-speed communication networks as well. And luckily this, unfortunately we haven't been able to, I will not be able to show you any results using this HPC for now. This is still that I will consider, we will consider this as a further work. But for now, we have been, this has been utilized in University of Canterbury. This is the PyGILE Plus in that cluster. And how it has been done is by just pulling the PyGILE Plus from our Docker, and then a CIF is created. So if you can see here, this is how the interface looks like for the HPC. You see, this is the PyGILE. So the number of hours, the number of cores, the memory allocation, and all of that we can give. And based on that, we can create a Slurm job. And based on our data and our computational time, we can just use it. So that's the HPC part. So I mean, it's kind of confusing. So what is the gist? So I'm going to finalize this with certain aspects. So the reason PyGILE was developed is because there is a wide need for a geospatial framework where we will be able to understand everything in Python for geospatial from the grassroots level. So that's why PyGILE was developed. And for the PyGILE Plus, in addition to the existing Python ecosystem, we also needed all the GISs to be inbuilt into the same system. So that's why we created PyGILE Plus. And why the HPC? Because sometimes we have a large amount of data that we need to run, and we don't want to go through here and that. Just using the same existing environment that is running for all, we will use that for the large amount of data sets. So for researchers and for the other use cases, I mean for educators, researchers, it could be useful. So although this research feels incomplete for now, because it just showcases that something can be used. The development part is already there, I mean PyGILE and PyGILE Plus. However, we are looking into some other things that we could do later on. For instance, like the deep learning integration, although we already have the deep learning packages there, but how does it work in the HPC? Or how the large scale results look like? Or do we face any issues while running into the HPC clusters? Although, as reported by the University of Canterbury, I mean, we couldn't see, not personally communication, however, we couldn't see any issues being reported there. So we believe it's working fine, but to look for it again, these are some future scenarios that you can look through. And yes, in the university courses, workshops, and online learning and those kind of things, this could be useful as well. Thank you so much, I think.